talking about the physics of surfing. And first we're going to talk about waves.
Wait, you mean this kind of wave?
No!
Oh, this kind of wave!
Yes! But first, what kind of wave is an ocean wave? It's a surface wave. A wave that displaces matter parallel and perpendicular to the direction of the wave motion.
Oh!
Stop.
That's cool. That's
As a wave approaches the shore, the depth at the crest is larger than at the trough, where the speed is lower. So the crest overtakes the trough, the peak sharpens, and the wave ultimately breaks. Guys... Well, a crest is the high point of a wave. And as the waves move through ever shallower water on their path to the beach, their speed decreases and they may be seen to retract so that they become more and more parallel to the shore. The average speed of a wave is 6 knots average. And the speed of the incoming wave is initially determined by its wavelength in deep water. And this in turn is dependent on the distance over which the wind has blown in the rising wave. Anyway, since the wave generally approaches the beach at a shallow angle, the point at which it breaks runs along the crest. And if the surfer can move at this same speed, he can travel very rapidly parallel to the crest. That's all we have on waves.
Hello, I am Jeebus. Today I will teach you about gravity. Okay, gravity pulls on every atom in you and your board, yet it acts as if it were on one force acting at your center of mass, which is usually located just behind the navel and the middle of the body, like this, like this. Okay. Oh, any questions, anybody?
But what is gravity?
Oh, I'm glad that you asked that. Gravity is the attractive force between two masses, like, say, me and the earth, okay? Okay, you got that? Like me walking on this water. See? You see, I do a fine job of walking on the water. Oh, okay. Well, since I didn't have any gravity, I kind of fell. Oh, I fell a lot. Okay. Cut.
Now we're going to talk about the buoyancy of the board. Buoyancy is an upward force created as the still water pushes up on the board, a hydrostatic force. Hydrodynamic forces are the forces exerted on the surfboard by moving water. The water exerts force on every part of the board that is touched, but the buoyant force acts as if it were one force pushing up at the center of buoyancy, which is the center of mass of the water displaced by the board. Net force. Since you are not accelerating, and according to Newton's law, the sum of all the forces on you is 0, this is called the net force. Note that you can still be moving at a constant velocity even when the acceleration is 0. Acceleration produces changes in velocity. As you push your water backwards with your hands when paddling out, by Newton's law of action and reaction, water pushes forward on you, accelerating up to speed. The board and the rider must somehow accelerate up to the wave velocity. There are 2 modes of acceleration as the selective wave approaches, paddling forward as hard as possible and then allowing the wave itself to accelerate to you.
I am Jeebus. I have a great magician. Your sweater is off. Look, I am a great magician. Her sweater is off.
Well, now we're surfing. After accelerating up to the wave speed, the rider rises to a standing position, as you see here, and begins rapidly skimming over the water surface, even though the average density of the board and surfer combined is quite high. But the wave becomes steeper as it advances, and to avoid a spill, the rider must move down the front of the wave to where acceleration is less. This provides stability. As the water rises under you, you find yourself on a slope. Gravity is pulling you down the slope, buoyancy pushes you up, and new forces, hydrodynamic forces, from the interaction of moving water with the surfboard, pushes you forward. Dropping down the face of the wave equals a gain in kinetic energy, and a loss of potential energy while gravity pulls you down, turning up the face of the wave. Loss of kinetic energy and gain in potential energy rising to the crest of the wave. And the distance it is possible to travel directly towards shore is relatively short. If the breaking cycle surfing of the beach. The weight of a rider at the front of the board could be balanced by the weight of the board acting as its center of mass. Running forward causes the board to accelerate out of a wave, and the rider must quickly move back. Kind.
Now we're going to talk about surfboards. Because of the surfboard's large area, they experience relatively large frictional forces as they move over the water. The smaller the board, however, the faster it must move if the board and the surfer are to plane rather than sink. On a long board, you step back and shift your weight to the right. On a short board, you shift your weight back and right. Put your weight more on your back foot, then weight the heels or toes, whichever is on the right side. Short boards are short, with thin pointed noses. Long boards are long, with wide rounded noses. If you pick up a short piece of wood, a foot long, 2x4 for example, and try to twist it rapidly side to side, you'll find it's easy to turn. But try that with the 3-foot long, and the turning motion are slower. A longer, heavier surfboard.
Keep going.
I'm sorry.
Surfboard,
A longer,
surfboard.
heavier surfboard turns more slowly than a short, light one. The resistance of the board to rotation is its moment of inertia. Long boards are slower to turn, but go faster when you paddle them because they have a higher hull speed. This is because a boat or board makes its own waves as it moves throughout the water. At the hull speed, the wave makes it is highest at the front of the board and lowest at the rear. The board is always going uphill. If the surfboard were to slide through the water sideways, the water would hit the fin or fins at the rear of the board with a strong sideways hydrodynamic force. This force would twist the surfboard around its center of mass until the board aligned with the direction of motion. The fins help turn by keeping the surfboard from sliding sideways across the water.
And that's all we have for
What? Physics and science.
Yeah.
So what, I mean,
surfing.
Physics of surfing.
Surfing.
She said,
I think we're high on crackers.
Roll credits.
AAAR Productions presents.
Films by K&H.
I guess not. Unofficial sponsor, Pepperidge Farm Goldfish, Baked Snack Crackers.
And Jesus.
Everybody's gone surfing. Surfing USA.
And Jesus.
Surfboard pants!
And Jesus surfs too.
Okay.
Go get a snack. Perhaps a carbonated soda. Meow. This is forest.
Do. Hey, thought you were supposed to say something. Guess not.
Retarding wave. Well, this is what happens when mommy and daddy get polluted.